Hi everyone, this is Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the general introduction to the normalization. Before seeing this thing, kindly watch my previous video. In that, I have detailedly explained about the functional dependencies and all. So what do you mean by normalization? Normalization is nothing but we're going to minimize the redundancy from the relation or a set of relations. So there we have to use certain process for minimizing the redundancy. So redundancy, how it can be occur means it can be causes while inserting a record, while deleting a record, while updating a record in a database. Through that, as a normalization, it will help to minimize the redundancy in our relation. Not will be eliminating the redundancy, only we're going to minimize the thing. For that only we are using a several normal form can be used to reduce the redundancy present in our table or a database. So for example, normalization is nothing but we are repeated data. Either we have to enter or we have to delete the record in the particular table. For example, if you're considering this is my table, it can contain ID, name, credit, department name, building, and room number. If I want to, this is a larger schema. If I have to, under the CSC department, if I have to change the building number as B1 to B7, for example, I'm going to update my CSC department number, their building is B7. If this particular record can have 1,000 or 10,000 entries, each and everything I can't able to enter the thing. For example, I have to search the CSC. If it's CSC search, I have to enter B7. B7. It is a hectic process, is it right? Am I right or wrong? So it is a hectic process. So this can be avoided by using a normalization technique. For example, if I want to change the HOD phone number in this particular table, see through that, I'm going to update a HOD phone number. So I'm going to normalize this particular table into a different name. For example, HOD name and HOD phone number. In this, I can able to have HOD of CSC, HOD of IT. So in this particular record only, I can able to update. So in this thing, I can't able to search everything. If I want to change the department name to the building number B1, if I have to add it in this thing, so I don't know whom I have to do it. So if it doesn't have, it will take a null value, but this only updated. This is not a consistent database, is it right? So this can be avoided by using a normalization. So these are the only we can call it as a insert. While inserting the value also we have to problem. While updating the value also we have problem. If I want to remove the ECE department, I can able to remove only Akash. I can't able to remove the ECE department. Is it clear? So through that only a redundant data must be present in our table. So this can be avoided by using a normalization technique. Why do we need normalization? Means we have to remove all the anomalies and also we have to eliminate the anomalies that leads to data redundancy. Only through the anomaly only we can acquire the data redundancy. So it will cause us the data integrity and other problems in our database or a table. But also majorly these type of anomalies, that is insert, delete and update, we can be call it as a data anomalies. So for removing this only we need the normalization technique. So first we have to see one by one anomalies because this is a very important 2-mark question. So while doing any modification in our database or a table only, we can cause the data anomaly. So there is a 3 different types of a database anomaly. One is insert, delete and update anomaly. Insert anomaly is referred to when one cannot insert the new tuple in the relationship because it is a lack of data. If I have department name only, I don't know the person name, means this is a in lack of data. Through that also we can cause them issues. If you delete this thing, if I want to remove the ECE department in my table, so I can't able to remove the ECE department, only I can able to remove that particular person. So this can also cause an unintended loss in my data. And also if we want to update, I have to one place if I have updated in one another places I can't able to update it. If it is a multiple row is present in the, this also cause an error. So these type of anomaly only we can call it as a data anomaly. So this is how I have to assume I have to did in the example in the same row. If I want to insert new value, If it doesn't have a name and credit, means this is called as a insert anomaly. If I want to update the C1, here I have updated, here it doesn't update, means this is a update anomaly. If I want to remove the ECE department alone, I can't able to remove, because Akash only I can able to remove, I can't able to remove the ECE department. So this type of anomaly is the example for insert, update and delete anomaly. So these are the major thing where we are using this type particular thing, can we call it as the OLAP and OLTP. So this I am going to detailedly explain in my another video what is OLAP and OLTP, because OLTP should not contain the redundant data. So it will need only the normalized data, but analytical processing, we can have the either it can have the normalized or unnormalized. That is not a problem in analytical processing, but in transaction processing, definitely we should not contain any redundant data. For that only we are going for the decomposition of our relation. Through the decomposition, so definitely redundant data can be removed. So all your anomalies can be removed. For that only we are using a normalization. These are the few benefits of by using a normalization. Reduce the redundancy from a table, compact the data, or we can save the space. We can able to remove the all type of anomalies, and also we have to minimize the null values, and also your simplify the queries, and also your database structure will be similarized. So these are the introduction about the normalization. In next video, I'm going to explain about the each and every normal form. Thank you for watching my video.